Welcome back to the lab again. For this week's experiment, we're going to do something that's not quite as involved with as many pieces as we did last week. What we're going to look at this week is we're going to look at a salt that when it crystallizes as a hydrate. This means that when this particular compound goes into its crystalline form, it traps some waters there. How many waters it traps, that's what you're going to determine. Now, in your lab manual, there's a sample calculation that looks at a copper 1 sulfate pentahydrate. Okay, so if you were to heat that particular compound and you were to take the measurements like you're going to take for this particular experiment today, you would be able to figure out the ratio of the number of waters to the number of copper 1 sulfates in the formula. And so you do this by massing out your compound at the beginning of the reaction, heating it up so that all of the water evaporates away, and then massing it out again when you are all done. The difference between those two masses is the mass of the water that was evaporated. From that mass of water, from the molar mass of water, you can figure out the number of moles of water that evaporated. Okay? The mass that's left behind, that's the mass of just your compound without the hydrates. And so from the mass of the compound and the molar mass of the compound, you can then figure out the moles of compound. And then doing a ratio of moles of compound to moles of water, you can figure out how many waters go in that formula. All right, you're going to be looking at not a copper sulfate, but a magnesium sulfate. So you're going to be looking at Epsom salts. So Epsom salts are a common compound. You can find them in the grocery store. In fact, I particularly enjoy, after I've been on my feet for a long day, soaking my feet in an Epsom salt like bubbly bath thing. I have one of those like home foot spa things, and so Epsom salts are super relaxing. Okay? Some people like to soak like in a full body bath of Epsom salts if their muscles ache. All right, so what are you going to need for this experiment? From your equipment kit, you're going to need your balance, you're going to need your tweezers or your forceps. Okay, from the materials kit, you're going to look at the bag that says decomposition of a hydrate. Okay, additional supplies that you will need involve your PPE. So I already have my lab coat on. I'm gonna put my safety glasses on. I'll put some gloves on. Okay, and I'm going to put another pair of gloves on. All right. In your materials kit, you will find 3 little dishes. You will find a can of sterno. This is your heat source. You will find your Epsom salts. And you will find this little stand that it's all going to go on. Okay? It also says that you are going to want something to light stuff on fire with. Okay? You'll want some sort of oven mitts or tongs to move stuff around. And then we've added in there a trivet, so you can put your hot stuff on there. So I grabbed a trivet. Okay? The other thing that I would recommend that you get out of your equipment kit is a spoon. It's going to ask you to do this experiment 3 times. So this pouch of Epsom salt you have, you're not going to dump the whole thing out all at once. You're going to weigh out a small amount for the first trial. Then you're going to weigh out another amount for the second trial. And then you're going to weigh out another amount for the third trial. It's much easier to do that and to control how much you're weighing out if you scoop it with a spoon instead of trying to pour. All right? So I would recommend getting a spoon out of your equipment kit. Okay. So to get this started, what we are going to do is we're going to label our aluminum dishes. So the other thing I recommend you grab is that grease pencil. Okay, so you're going to do 3 trials. So I'm going to label my dishes 1. I'm going to label them on the little tab there. Okay, I'm going to label 2. Okay, again, I'm going to label that on the little tab. And I will label number 3. Okay. All right, so I've labeled all 3 of my dishes so I can do all 3 of my trials. Okay, you can go ahead and open up your sterno. All right, so you're gonna take it out of all the packaging. You should be using this can of sterno just the once, so you'll put that on your trivet there. You can go ahead and throw the rest of this stuff in the trash. Okay, you will take the lid off of your sterno. Now this can be a little bit difficult. I oftentimes need something else to leverage under the lid of sterno when I am going to use it. So I've got this handy little other lab scoop in here that I'm going to use to go ahead and pry off the lid to my sterno. You can use whatever other thing you have. So mine's got this little flat end. Okay, the sterno is this ethanol gel stuff. Okay, so you'll see it's just this kind of gelatinous stuff in there that will light on fire. All right, so I'm gonna put my sterno there. I'm going to put my stand there. And now I'm going to get set for my first trial. Okay, so what I need to do for my first trial is I need to get some data before I light anything on fire. So I'm going to turn my scale on. All right, if I turn to my data table on page 9 of the procedure, it's going to ask me for the mass of my aluminum dish. Okay, so I'm going to put my aluminum dish there on my scale. My particular dish is massing out at 1.27 grams. So I'm going to record that with units on my data table, 1.27 grams there for trial number 1. Okay, now I need to go ahead and add in my Epsom salt. Okay, it tells me to measure approximately 0.3 to 0.8 grams. Okay, so if I have 1.27 grams already in there, I want to put somewhere between 1.57 to like, I don't know, 2.07. Somewhere in that range is what I want the final number on the scale to reach. Because remember, the amount of Epsom salt is going to be the total number on the scale minus the mass of that aluminum dish. All right, so 0.3 grams added to the 1.27 would be 1.57. And so I want to keep somewhere in that 1.57 to maybe, 2 grams. The larger sample I have, the longer it's going to take for all of the waters to burn off. So I'm going to try to stick to kind of that mid-range of that range that they gave me there. Okay, so I'm going to take my spoon and I'm going to carefully put some in there. Make sure you don't let your balance turn off, as mine just tried to do on me. There we go. Okay. So keep an eye on your balance. They do like to turn off. So again, I'm just going to tap this in there gently. All right, I'm at 1.92. So that's good. I'm going to be somewhere in that range. I'll put the rest back into my little baggie. I'm going to close my baggie and put these off to the side. Let's see, I'm going to put them over here where they're not in the way of what I will be lighting on fire. Okay. And then I'm going to go ahead and record that final number. Okay, I let it sit for a moment and it finally settled at 1.95 grams. Okay, so there we go. Okay, now to do this, I will place this on here. I'm not actually going to light mine because this stuff does burn for about 45 minutes, which is perfect for the duration of your experiment, but I don't want to sit out here for 45 minutes waiting for this to finally burn off. All right, so I'm just going to leave it like this to show you how it's set up. What I would do now is I would go ahead and I would light my sterno. Okay, so I'm going to light my sterno and I am going to start heating that up. Okay, now what I will do is I will allow this to burn, and while it is going, I am going to just kind of let it do its thing. Your instructions say to allow it to heat for 10 minutes. That should be fairly sufficient. What you can do while that particular sample is heating is you can go ahead in your dishes 2 and 3, you can start getting those initial masses while you are waiting. All right, so this is burning, so I'll turn my balance back on, I'll get dish 2, I'll mass out dish 2, I'll put the mass, I'll add my Epsom salt, and then I can set those off to the side, and those will be ready to go as soon as this one is done burning. Okay, as soon as this is done burning, you want to go ahead and remove this dish and get the next one going. You do not want to mass this out right away though. If you mass it out right away while it's still hot, you won't get an accurate mass. You do need to allow it to cool. So you might want to have another trivet standing by, or just something you can set something hot on. So I've got these cloths out here, so we'll pretend this is super hot. I'm going to be very careful. I'm going to grab it with my tweezers. I'm going to set it there. I'm going to let it cool. And now I will grab my next pre-weighed, ready to go dish, and I'm going to set that on there. I'm going to use my tweezers. Although my dish isn't hot, this is hot. And so I'm going to be careful about letting that go on there. And I'm going to repeat the same thing. I'm going to go ahead and let it burn. Now, while that's burning, okay, and it's evaporating off all of my water, so my sterno's burning, my compound is hot, my water's evaporating. All right, I can start doing some of the calculations, not all of them, because I still need more data. I need those final masses. But, looking here, it says massive aluminum dish plus Epsom salt. And then it wants to know the Epsom salt mass, the original hydrated mass, i.e. the original stuff I put in there. So I'm going to get a calculator out for that. Okay, I've got my calculator. Coincidentally, on the next page is a totally blank page that says notes. I can do my calculations here on this notes page. So I'm going to go ahead and put trial 1. Okay, so I need to know mass of hydrated Epsom salt. Okay, so I'm going to put that down. I'm going to label it so that I know what I'm looking at. And so the mass of my original hydrated Epsom salt is just the mass with the dish minus the dish. So I'll take my 1.95 grams minus my 1.27 grams, and I will get 0.68 grams, which is between that 0.3 to 0.8. All right, and so I can do that. Now I'm going to have other calculations to do with trial 1. So if I have these other dishes weighed out and I want to start doing that calculation, maybe partway down this page, or I could put trial 2 on the back of this page. And then if you printed the whole thing out, there's another page that's blank that prints out after that. And so I can do trial 3 on that third page. That way I keep all of my calculations nice and neat and organized. And I'm not trying to do trial 1 calculations and then do a calculation for trial 2, but then go back to my trial 1 calculations all in a big mess. No, I'm gonna keep everything nice and laid out so that when I go back later, I can go ahead and analyze everything, okay? So I've done some of that. Okay, let's say this one is done heating. All right, we've taken our 10 minutes. I'm gonna take this off. Okay, I'm gonna let that one cool. It's still heating. I still have a third one to do. I can start that one. Now, after 10 minutes, okay, this one should be cool enough to go ahead and weigh out. So I can go ahead and place that on there, and now I can get my mass after the water evaporated. So I would get my mass, and then where it says mass of aluminum dish plus Epsom salt after heating, that's where I'll write that number down, okay? Now it says Epsom salt heated dehydrated mass. To get that number, I'll take the mass of my Epsom salt at the very beginning minus whatever I have left over, okay? And so that's going to give me the mass of my water there. And then my mass of my salt that's been heated afterward, okay? So if I take my dish with my heated salt, and I know the mass of my dish, I can take the dish with the salt minus the dish, and that will give me the mass of just the leftover salt, okay? So again, you wanna go ahead and make sure you are careful with all of your numbers, okay? Pay attention to what you're putting together, what masses you have. So again, at the very end, when you weigh this out, that's going to be your salt after heating. And then to get your dehydrated mass, you'll take the dish plus the salt after heating minus the dish. To get your water, you're going to take your original hydrated mass minus your dehydrated mass. So the difference between the hydrated and the dehydrated gives you your mass of water, and then you can do your mole calculations. All right. And again, while your samples are heating, you can do some of this. So, sample 3 is heating. Sample 1 cooled. So I got that mass. And now I can go ahead and do the rest of those calculations. I can get the mass of my dehydrated salt. I can get the mass of my water. I can do those mole calculations. All right. So I can follow the rest of that through, and then I can get those ratios. Okay, once the time is up on sample 3, you can go ahead and take that off, and then you can take your sample 2, all right, which should be cool now because you let it sit there for those 10 minutes. Okay, and then you can weigh that out. Now, if it still feels warm to the touch, if you try to pick it up and this still feels warm to you, let it cool a little bit longer. You want to go ahead and weigh it when it feels like it's at room temperature. Those 10 minutes should do it, but if you go pick it up and it's still a little warm, let it cool a little bit longer. Okay. Now your sterno, according to Carolina, these particular cans are supposed to burn for about 45 minutes. Your experiment should run for 30 to 35 minutes. So there shouldn't be a whole lot of time left after you are done with your 3 heatings to allow this to finish burning out. It is important that you let this finish burning, all right? And it's important that you stay with this the whole time. Anytime we light something on fire in the lab, we do not walk away from it. So yes, these have to sit for 10 minutes in heat, which is why I recommend work on those calculations while this is heating. Gives you something to do. Do not walk away while this is on fire, okay? No leaving unattended flames. All right, and so once you've done all 3 heatings, again, you can sit here and work on calculations while you let this burn out. As soon as it's done burning out, you'll need to let it sit for a while longer because it will still be very hot. This will be hot, and this will be hot. This is going to look identical when it is heated to when it is cold. So once this is done burning out, don't touch anything. Just let it sit for a while longer, let it cool down, and then once it's had time to sit for a while, then go ahead and clean it up and make sure that it has adequately cooled down. Okay? Your dishes and everything, you don't need to clean anything out with water for this particular experiment. We're not going to reuse these aluminum dishes. They are just for this experiment. So when you're all done, instead of having to clean stuff and let it dry, you can just chuck your trash away when it is finished. Epsom salts are something that we do use at home. So you can throw those away, or if you feel better, you can go ahead and rinse those down the sink. But then you'll throw the aluminum pans away as well. Okay, so that is this week's experiment. Not as involved as the one that we did previously, but it's an excellent illustration of these stoichiometric ratios that we are talking about now. And it lets you see just what happens when you have a hydrate, because when you heat it, it will look different when you're done and you will get a mass difference. All right, so that is this week's experiment. Good luck. I hope you enjoy it, and I'll see you next time.